Shri Darshan sir, who is an MTech in automobile gold medalist, having 23 years of experience in OEM and service industries, worked with the multiple global EM and JLR companies such as Tata Motors, Mahindra and Mahindra, Hero MotoCorp, Volvo, VinFast, handling additional responsibility and managing graduate recruitment and diversity hiring. Sir has been working with Tata Technologies as a global head chassis center of excellence for last 11 years. Now I would request Sir Darshan sir to share his thoughts on innovation and project engineering. Please join me in welcoming him, Albert, virtually.
Hello, good afternoon, guys. How are you all? Good. It's always been a pleasure to interact with young folks like this. Incidentally, I'm also in charge of campus recruitment and university relations and all that. In collaboration initiative. So it's great to be part of this meeting today. And Today we'll be talking about mega trends in automotive engineering. Incidentally, I take care of the chassis engineering center at Tata Technologies globally, and deal in multiple Indian projects in the field of automotive, aerospace, as well as industrial. So, in today's session, I will just briefly touch upon what are the key mega trends in the automotive industry, what are the disruptions that are likely to happen, and how the technology is evolving in terms of cars, especially I will talk more on passenger car because probably this gathering is more relevant to that. And also at the end, we will see what is expected from young folks like you, right, to be successful. So to start with, this is the best time to be an engineer. The best time to be an engineer, and I'm glad that all of you are on that journey. So, very exciting future lying ahead of you, and I'll quickly take you to that. Just let me know once you can see my screen, and we start from there. Can you see the screen? Like any one of you sort of that you can see the screen?
Yeah, that's
Great, fantastic. So let's start by looking the automotive mega trends, right? What are the key trends or the mega trends that are going to happen next? Let's say over the. So this is what we touch upon today in the 30 minutes. You will see what are the four major transitions that are going to happen or that are happening in the world of automotive industry. What are the challenges and market drivers? We will briefly touch upon platform development, energy propulsion technologies, autonomous driving. I'm sure most of you have heard at least what is autonomous driving. I'm assuming that the audience today makes all branches between mechanicals and electrical. Please heard of this automotive autonomous driving. Also, we'll see what's a smart chassis and body engineering. What are the trends, right? So, when we say where the automotive industry is headed today, globally, right? We see four major trends, and we call them ACEs. So, what is ACEs, right? First is autonomous driving, right? Now, we all have heard or read about ADAS, Advanced Driver Assistance System, right? So, what is that ADAS technology? It's basically assist the driver of the car in all aspects. right? In terms of driving safely and driving comfortably. So it also helps to reduce the accident frequency. For example, there is a very simple ADAS feature which is called as adaptive cruise control, right? Some of you who drive the cars, rather new age cars, you will find this feature in your car. So what is, let's say, cruise control? Cruise control is something like you set the speed of the car and you take your foot off the accelerator, still the car will move with exactly the same speed. Let's say you set the speed at 80 kilometers per hour, the car will continue to run on 80 kilometers. This is cruise control. What is adaptive cruise control? Is basically if the vehicle in front stops or suddenly brakes, your vehicle will automatically go and stop, right? So that is adaptive. When the vehicle in front again starts moving faster, you will again regain the speed. So this is called as adaptive cruise control, one of the ADAS features. So what will happen is, typically in earlier days, what used to happen is, if the vehicle in front is braking, there are likely chances that if your vehicle is very fast, you will go and hit the vehicle, right? So that creates the accident. So this was just an example of how ADAS is helping us to reduce the accident frequency, right? Improving safety. And of course, not in India, but in foreign countries, the insurance premium is really a key driver behind selecting the vehicle, and then the vehicle which is equipped with ADAS will obviously have lower insurance. What is the second mega trend out of ACES? What is the C? C is connected, right? Earlier, vehicles were like standalone set of wheels, right? Moving from place A to place B. But now, there's a lot of communication. So earlier the car was mostly mechanical. Now it's almost 50-50 mechanical and electronics, right? So vehicles can communicate with one another and the outside world, right? And you have the navigation systems, vehicles picking up signals from, the objects on the road and analyzing it, and then actively aiding the drivers to reach their destination, right? It also helps them, or it does some tasks. For example, very simple this thing now, with the press of a button on the steering wheel, you can say call your friend or something, or you can say play this song or something. This is all about connected cars, right? This was not possible earlier, but now you can see this trend is very common. So we have seen autonomous, we have seen connected. What is E? Of course, everyone knows it, right? Electrification, electrified vehicle, EVs. Especially in India, EVs are the big trend, right? The gas prices are ever increasing, right? And electric vehicles have gained a lot of popularity, especially economies like India. And also, there's a growing concern over the global warming, and electric vehicles are seen to be crucial for this improving transport efficiency and lowering the CO2 emissions, right? You might have recently noticed last week there was a COP28 summit in Dubai, and the emphasis is again given on EVs. Even in your cities, you will see a lot of electric buses being operated. So right from two-wheelers to cars to buses, electrification is the mega trend that we see going forward. And what is the fourth one? S is shared mobility, right? So basically, the automotive market is now slowly shifting towards uh, you know mobility as a service, right? So you have shared electric scooters, peer-to-peer automobile sharing, and pooled ride sharing with strangers. Like you have apps like BlaBlaCar and so many other apps where mobility is no longer restricted to an individual, but it's a shared community. So you have seen this four ACEs, right? Autonomous, connected, electrified, and shared. So what we feel is that for at least next 5 to 7 years, the entire market will be driven, and the decisions of investments, decisions of recruitments, skills will be all taken around these four megatrends, right? So let's say how a new OEM, that is original equipment manufacturer, is working currently. So basically, what happens is earlier there was OEM. OEM is a company like Tata Motors or Maruti or Mahindra and Mahindra, whatever. The company which makes the cars, right? And then they are dependent on tier 1, tier 2, tier 3 suppliers for providing them the components and supplying the systems to them. Now, what has happened is, with the advent of these four mega trends, the car is no longer a set of mechanical parts. There's a lot of electrical engineering going on, a lot of electronic softwares, the complexity of car design has increased. And thereby, people are now needing somebody who is like between the layer 1 and OEM, right? We call it tier 0.5. And companies like Tata Technologies are actually playing a major role in being this tier 0.5, wherein we take care of the entire design and development process of the OEM, and then the OEM can solely focus more on strategy, and all the design work, development work is completely offloaded to the tier 0.5 companies like Tata Technologies, right? So, having understood the overall industry competition and where the mega trends are going, let's see what are the key challenges and market drivers for automotive industry. We call it Vision 2025 plus, right? So we will see what are the key trends, what's the vision, what are the key drivers to enable that vision, and what are the challenges in front of the industry as such. Let's say new energy vehicles. So I have sort of divided this into three columns, so to say. What's there currently, 2023? What's going to come in next 2 years, 2025? And what is happening in 2025 and beyond, right? I'm of course not going to read through the entire slide, but we will discuss on some of the key messages that are coming. So, for example, what are the market drivers currently? It's basically government regulation strategy, clean air, as we talk, COP28, profitability, right? But going forward, the regulation is of course will be the key driver. But again, reducing congestions, because as you can see, the traffic problems are increasing day by day. So reducing congestion will be one of the key market driver, and also the passenger count, right? And if we talk about trends, currently we're talking about air quality. You all must have read, North India air quality was really bad a few days back. Of course, COP reductions is one of the key trend. And basically, if I talk about the design, the cost reduction through modularity, more and more cars are getting designed with a modular approach. And what is a modular approach is, you design something as a unit, and the same thing can be used in some other car or some other platform. For example, to make it very simple, okay, let me give an example of a wheel. Let's say I design a wheel for a car, and I design it in a modular manner, so that the same wheel can be used on another car. Which means I don't have to invest time and money in redesigning the wheel for that another car. I simply make sure that when I am designing let's say, wheel for car A, it is also used on car B, right? This is modular. But what's the trend going forward? Lightweight. Of course, you all know that electrical vehicles, the lighter they are, the better it is for their range, shared mobility, and predictive ride. So it's no longer like I have come across a ditch and that's why the car has sort of given me a shock or something like that. It's a predictive ride. So the technologies actually predict the road ahead and then change the configuration of the suspension to give you a more stable ride, right? In terms of vision, if you see uh, artificial intelligence, zero tailpipe emissions, enhanced user experience using AI are the current trends. But going forward, you have intelligent mobility, which means smart cars, longer range, right? Um, uh, we are talking now about a range of almost 1,000 kilometers in some of the Tesla cars, right? And if you see 2025 and beyond, you have driverless transportations. So we will talk in detail more about this ADAS and autonomous level 1 to autonomous level 5. But there are already some cars or some prototypes being made which are completely driverless, right? It's a full autonomous, level 5 autonomy. So there are no controls. You just have to go and sit in that car or whatever it is called and enter your location. It will make sure you reach there, right? Without any human intervention. Again, sustainable transportation, sustainability is the key. Even at the end of the life of the car, at least all the material should be recyclable and sustainable and so on. And also, it will be fully digital way, right? So less and less of mechanical parts and more of digital technologies are being used. Talking about enablers, you know, currently, you government incentives, especially for EVs, are the key trends. You have seen a lot of electric buses being promoted by the government. So, again, processing power, which means the computation power, and one of our own product I have just included in this deck is Tata EVMP. It's electric vehicle modular platform. It's our own design. We have designed a platform which can be adapted by any OEM to bring out their car. Of course, I'll not go through entire thing, but the challenges, yes, cyber security remains one of the key challenges because, as I said, cars are getting converted from a pure mechanical part to more of supercomputer on wheels kind of a thing. The cyber security has seen never before importance. So one of the challenges, of course, cyber security, and cost of production also is going up. So uh, the industry needs to sort of address two challenges. Now, when we talk about platform development, uh, let's see what are the trends, vision, enablers, and challenges, right? So before that, just to kind of make it clear, what is the platform? I'm sure most of you know. You see picture on the top here. It is called as a platform. So it's basically the underbody, the powertrain, the entire chassis systems, and the battery for electric vehicles. Is called as platform. And when the car gets built over it, it's called as the top hat, right? So it will have all your human interface like seats, it will have trims, it will have the controls and everything. That's called the top hat, right? So what are the key trends for platform development, which means for chassis, powertrain, batteries, and so on. Of course, so market drivers, let's talk about 2025 in the interest of time maybe. Uh, Technology sharing amongst OEMs. And you would have seen this, uh, that currently Toyota and Maruti or Suzuki have been sharing so many models, right? For example, Maruti Baleno and Toyota Glanza, same models, right? Same platform. Or for that matter, Toyota Hyryder and Grand Vitara from Suzuki, same platform. They get sold with different badge, but the entire engineering and the components are exactly the same. So more and more OEMs are sharing the platforms, right? And that's going to be the trend going forward. Lightweighting, of course, is one of the key aspects of any automotive design going forward, because the lighter the vehicle, the better it is in terms of not only the range but as well as the cost as well. And safety for vehicles are going to become more and more safe. You know, you would have seen Tata Motors vehicles recently have scored excellent in NCAP ratings. All of them are almost having 5-star NCAP rating. So the structure has to be updated to give you all those safety features. So multi-load path structure for safety is one of the key elements. Licensing of platforms, we touched upon that. OEMs sharing platforms, 25 to 35 reduction of weight in terms of percentage, and compressing the time of development for vehicles. So earlier, I would see any car would get developed in about 30 to 32 months. Now it's almost 28 months as we speak. It's going to get further compressed for 24 months, and then going forward, let's say less than 20 months, right? Uh, and enablers are, of course, some of you would have sort of got introduced to CAE, computer-aided engineering, durability and edge crash. So instead of physical testing, we are slowly moving, they say, from road to lab and lab to laptop, right? So the testing which used to happen on ground, on maybe a proving ground or a test track, that will get shifted to a component test lab, and from lab it will get shifted to laptop, which means everything will be done virtually, and the correlation will be so strong that if the car design is clearing in virtual validation, you need not have to do the physical validation, right? So, of course, there are many points here, but we will not sort of go through. But in a nutshell, we are moving towards lightweighting. We are moving towards collaboration between the OEMs, and we are focusing more on digital technology rather than physical, right? Now, let's talk about what are the energy propulsion technologies, which means essentially the power, right? So, currently, what are the market drivers for power, right? Range anxiety, right? If you have a, let's say, EV bike or an EV car, most of the customers are range anxious. Let's say, what if my battery discharges while I am in the journey, right? What if I don't find another charging station, right? So that's called as range anxiety, and all the OEMs are currently working to address that. Faster charging. Let's say you are going from Belagavi to Bangalore, and then you don't have to stop somewhere, right? Just for charging your car. It should be like as if you are filling the fuel. Let's say not more than 5 minutes, and you should be good to go, right? You can't be waiting there for 2 hours for your battery to get charged and then move forward, right? Faster charging and environmental sustainability, right? Uh, again, just to see trends are cell format and size. So cell of the battery is getting compact, and also a lot of research is being done on solid state batteries, right? In terms of enablers, right? And I'll draw your attention to in 2025 what's the key enabler. It's basically battery swapping, right? Now what is happening is, if you take a EV car, almost 30% of the cost is only for the battery, right? And that is what is making EVs slightly expensive compared to IC EV cars. So what now the industry is thinking, that you own the car, but you lease the battery, right? You don't own the battery, you just lease it. And it's like going to a fuel station and filling fuel. You go to the battery swapping station, they will remove the discharge battery, they will fit a new one in less than 5 minutes, and again you are good to go, right? So that's a battery swapping technology. A lot of OEMs are working on this. Of course, in terms of challenges, heat and how we manage that heat. A lot of heat gets generated because a lot of high current transactions are involved, and so you got to manage the thermal. Technology highlights, just a second. In terms of drivetrain efficiency, right? What is the roadmap, right? So you're talking now about 800 volts of system. Now you all know that power, electrical power, is a product of voltage and current, right? So if you need to fill in that much of power in the battery and the voltage is less, obviously it means the current will be very high. And high current involves so many complications like heat, right? Then safety. You need that much of thick of wiring, so on and so on, right? So the industry is now thinking about 800 volt system, and the benefits will be that it will be, since very less current will flow through it, less heat. As I said, the reduced component sizes, because larger the current, thicker will be the wire. So for 800 volt system, it will be very thin. It will be reduced weight, of course. So thinner parts will have less weight, reduced cost and longer range, right? So so these are the current trends in the powertrain area, wherein many OEMs are now working towards 800 volt system, right? For the reasons given. Now let's say autonomous. We said one of the key drivers was out of ACES was autonomous. And I would want your attention to be on this picture. This is on the top of screen. I hope all of you can see. This is Amazon Zoox, right? This is a fully autonomous vehicle. You can call it pod, or there are a number of names. Right? Now you can see that there is nothing, no direction. You cannot say which is forward, which is backward, right? Which is front of the car, which is rear of the car. You can't make out. You can see only a door, right? And there are a few seats inside, right? There are no controls, no brakes, no steering, nothing. This is where the industry is heading. And after this maybe call or this session, you can Google Amazon Zoox, Zoox, fully autonomous. You just have to sit in that car, enter the location where you want to go, and will take you there. Right? It has got a lot of sensors, radars, lidars, lot of equipment and gadgets are sort of installed, which help the vehicle to detect the traffic, to see the signal, to see the pedestrians, and so on and so on, and it will eventually get you there, right? So, what are the current market drivers? Is basically shared mobility, as we said. Safety regulations. Safety regulations are becoming more and more stringent, and traffic congestion. Right? Everybody is facing the traffic issue. So, what is the trend? How do we take care of this? Right? Traffic jam shopping. What is traffic jam shopping? It's basically a feature where if you are stuck in a traffic jam, in a bumper-to-bumper traffic, you don't have to actually be active, right? Change the gear, press the brake pedal, release the brake pedal when the car in front moves, nothing. You just tell the vehicle or it senses that I'm in a traffic jam and it will keep on crawling, right? Um, Similarly, valet auto parking. So you have the park assist. So you just have to tell the car that it needs to park itself, and it will be right. In terms of vision, you have sensor fusion, which means signals from multiple sensors coming together and sort of giving the input to the ECU of the car. Vehicle-to-vehicle strategy. So the two vehicles will speak, right, with each other. Like in the case of aeroplanes, if the two aeroplanes come very close to each other, there is a system called as PCAS, traffic collision avoidance system, wherein the two aeroplanes speak each other and they decide how to avoid the collision irrespective of what the pilots have given the command, right? That's called as PCAS. And similar technology is now coming into automobiles as well, wherein if the two cars sense that they are going to collide, they will decide their own course and avoid the collision, right? So such trends are coming, and again, talking about challenges, you have cyber security, technology commonization, and networking challenges, right? Going forward, again, you have insurance implications, urban system infrastructure, because the infrastructure has to be that much more equipped, right? And road user safe. So let's spend the time. Siddharth, how much time do I have? Because I have not like noticed when did we start exactly. So can you tell me how many more minutes I have?
I think we have around like 15 minutes.
15 minutes more?
Yeah, 10 to 15 minutes.
Okay, and then we should have some time question and answer.
Yeah, you can have like 5 minutes for the question and answer.
All right. So yeah, talking about the technology highlights, we said advanced drivers assistance system, and what is the roadmap? So there are 5 levels designated, right, for ADAS, L1 to L5. So just briefly explain, at L1, level 1, you have adaptive cruise control. I explained you at the start of the session what was adaptive cruise control. And second is lane departure warning system. So if you are driving a highway and if your car deviates, let's say if the driver dozes off or something happens and the car starts to deviate from the lane, it will immediately give the warning, right? So you can see for level 1, number of sensors are about 6, right? And level 2 is a partial, right? So you will have lane keep assist LA, right? Which means it will help you to remain between the two bands of, there are white bands in the road. It will keep you between the two bands and park assist. Okay. Third is the conditional level, which is almost common in most of foreign cars in 2021, which is automatic emergency brake. Which means what happens is, uh, if the car senses that the driver is in panic, and whenever the driver is in panic, he will hit the brake pedal hard, right? So it senses that the driver is hitting the brake in a panic situation, and the vehicle will apply the brakes much faster than the driver would have applied, right? That is called as automatic emergency brake. Then you have driver monitoring. It will monitor if the driver is attentive or not, or if he is dozing off or whatever. And third is traffic jam assist. As I told you, it will keep the vehicle moving in a bumper to bumper traffic, right? If you guys have read today's newspaper, Kia have launched new Sonnet. I think they're featured in the first page itself. So just go and see what are the features. You will find many of those features in the new Sonnet, right? Uh, okay, going forward, level 4 ADAS. What is that? Sensor fusion, taking inputs from multiple sensors and combining those inputs to the vehicle ECU, and autopilot on highway, which means if you're on a highway, there are less traffic disruptions. You can take your wheels off the steering, you can take your feet off the controls, and the vehicle will still be moving, right? And level 5, which is likely to come in 2030, is full automation, which I told you, almost 32 sensors. You can see at the bottom of the screen, 32 sensors on the car, and the picture at the top looks like the future of the automobiles, right? This is the pod. I like this concept very much. Right? You just enter the vehicle, and it can be shared as well. Just enter where you want to go, and that's all. You can do your job, right? You can read a book, you can work on your laptop, whatever. You can have a good nap, and it will take you there, right? So this is where new technology is taking us, right? So we have seen propulsion, we have seen autonomous. We'll see how the chassis system is, right? What is the chassis system? Is typically suspension, brakes, axles, steering, all tires. This is all chassis. Again, so what are the current drivers that include NVH, right? People want quieter vehicle which do not rattle, right? Vehicle which ride smoothly. Then improve driving dynamics. You want the vehicle to handle very precisely, right? You don't want a sluggish vehicle, you want a sporty vehicle. And of course, extended durability. Uh, you don't want to kind of get stranded on a sideline of a highway with your bonnet open and all, right? You want a predictable durability. Trends are high mileage, of course, high durability. So no service request or service intervals or something like that. And semi-active suspension for a better ride, right? And of course, enablers are electronic power steering, vehicle sensor suits, and so on. In terms of future trends, I see X by wire coming very soon. We will talk a bit about that. It's basically steer by wire or brake by wire, right? Like in aeroplanes, even in cars, talking about by wire technology, which means there will not be any mechanical connection between the steering wheel, let's say, and the steering gear, right? It will all be sensed by a sensor and through a wire it will be communicated, right? So that's steer by wire. So we talked about trends of smart chassis. So chassis are getting smart. What's X by Y, right? If you see picture on the right corner, I hope you can see that. Right? To the left side, you have a steering system, which is a conventional. You can see the steering wheel, then the it's connected to I shaft, and then it is intermediate shaft, and it's connected to the steering wheel. Whereas, picture on the right is steer by wire. You can see that steering wheel, but there is no mechanical connection between the steering gear and the steering column, right? It's all driven by motors and sensors and wires, right? So, steer by wire and brake by wire, right, are the two key trends that we see coming in near future, right? So, for example, we learned about steer by wire. What is brake by wire? Basically, it replaces the mechanical link between brake pedal and the brake system, right? So, when you press the brake, an electronic signal will go to the caliper, brake caliper, and it will apply the brake, right? Of course, there are benefits and there are challenges. So, benefits are you have increased efficiency, responsiveness, you have greater design flexibility because there are less mechanical components. Improved safety and convenience because instead of human reaction, the artificial machine reaction is always quicker. Reduced weight and complexity because the number of parts are getting less, and reduced maintenance because there is less wear and tear, less friction. Challenges are, of course, it is complex, right? It's not yet fully reliable, right? Let's say 1 in million case, if you try and steer the vehicle and it doesn't steer, 1 in million, it will still not be acceptable, right? Your vehicle will go and meet with an accident. You have dependence on electronic components, and we know that sometimes, like our mobiles, electronic components can fail or can malfunction. So, how to address that, right? And of course, cost, because you are talking about steer by wire technology, which includes a lot of high-end technology, sensors, and so on. So obviously, the cost is going to be high, right? Just an example of predictive suspension. So currently, what happens is we are driving on a highway, and if there is a sudden ditch that comes, we get a shock, right? We get a bump. So in predictive suspension, what will happen is that it will sense that there will be sensors installed in vehicles which will sense. For example, I'll not make it too complicated, but if you can see the picture on the bottom, you can see there is a crater here. The vehicle will sense that, and accordingly, it will give a signal to the damper of the vehicle, to change its damping force, so that when the vehicle actually goes over this bump, you will have very stiff suspension, and you'll get a better ride. So you can see the graph plotted here. The graph with larger deviation is the conventional reactive suspension, and the red one is the predictive air suspension, right? So I'll not make it too complicated, but try and understand that currently our suspension systems are completely passive. They do not react depending on which road you are driving. But going forward, we will have predictive suspensions and active suspensions, which will predict that there is a ditch on the road quality is not good, and accordingly they will change the vehicle settings to give you a comfortable ride. I'll briefly touch upon body engineering, and then I'll stop. Maybe in the interest of time, we will have some time for question and answers as well. So, again, one of the big mega trend coming in body is mega castings. You would have seen Tesla Model Y or Model 3, right? It's rather than sort of making it of sheet metal, building multiple sheet metal parts, companies are more and more switching towards the mega casting. So you make a whole big casting of the entire front and the entire rear end of the body, right? So what is the advantage? Is of course you have only one single part. Right? You don't have to weld too many parts, sheet metals together. So it reduces the weight of the vehicle, which of course improves the fuel efficiency. It improves the structural integrity because you have one single part, right? Not multiple parts welded together. It can be produced at a high scale and a high speed. Basically, reduced body shop and manufacturing lines and robots. If you have seen on YouTube how a car body shop is manufactured, you will see a big line setup and then multiple robots work welding parts together to create this. So that entire thing is gone. You just take the casting out, you machine it, and your body shell is there. Of course, reducing part count, improve body structure, manufacturing accuracy. Because when you weld two parts, the inaccuracies are bound to come with that, right? But if it is machined out of one single casting, it has much better accuracy in terms of dimensional conformance, and that gives a better quality product, a better ride, or whatever, vehicle performance is in it, right? What are the challenges? Initial cost is very good. Imagine you are to set up a big giga casting, machine setup. Porosity, of course, which comes inherent with any casting. Safety, because if there is some crack, let's say again 1 in million parts, there was a crack, and in the event of a crash, the vehicle did not behave the way it should be, then it's a fatal accident, right? So safety is one of the key aspects there. Repairability, of course, if your part is made up of multiple parts and one of the part breaks, you can simply take that part out and replace it with the new one. But imagine if the entire car shell is made of one single casting and something happens to one small area, you still have to replace the entire thing, right? So repairability aspect is very less in terms of mega casting. And of course, insurance cost, because the replaceability or repairability element is low, the insurance costs are high, because insurance companies will have to consider that even if a small damage to any part, sorry, somebody saying to me?
No, you can continue.
Siddharth?
You can continue.
Oh, alright. So I'm almost done. One last slide. I understand there are a lot of young folks in this section. So, after understanding all these key trends of automotive industry, and we touched upon few of the trends in powertrain, chassis, autonomous driving. How is that you engineer the next, right? So the technology aspect can be taught. I have enlisted few key expectations from you. If you guys have to excel in your field, I'm sure you're looking forward and career ahead of you in next 2 3 years. And as I said, the best time to be an engineer because uh, uh, we are in a disruptive era. So many new technologies are coming. India is looking like, and you guys are going to be the flag bearers of the economy going forward, right? So this is a non-technical slide, but I wanted to sort of run you through this. So what are the 5 I's for you to excel and become successful? Is integrity. When you join the organization, make sure that you are fully involved in terms of integrity, right? Your words and your actions be aligned, right? Inside, in your organization, if you're able to see the nuances of change, certain events that eventually lead to big business impact. Means you have to keep your eyes and ears open, right? And see what's happening around. Innovation. This is the key. We are having a series of innovation movie, like this big top part of a big innovation initiative, right? So currently, business which does not embrace innovation to fail, right? Every company is now focused on innovation, and you are the flag bearer on that because you have fresh ideas, you have new thoughts. So always keep on thinking how something can be done in a way more efficiently, right? Take initiatives when you have companies. Make sure that you are not waiting for something before you take initiative. Uh, express your ideas, and I'm sure your seniors will appreciate that, right? And finally, intelligence. Continuously gather and synthesize the information, right? Read the new technologies. Now, many of you would have known about some new technologies, new trends coming during this session. Go and sort of further deep dive. Make yourself more aware of what's happening around. And I think this gathering this intelligence about the situation will really help you also to crack some of the interviews, probably some of the applying for campus interviews or something like maybe interviews in the company. So all these 5 I's, grit, insight, innovation, initiative, and intelligence actually help you to excel in future life. Right. So with that, I conclude my session. I hope it was informative and it helped you to gain some of the insights. I'm happy to take invitations. Thank you. And I can see, I must be hearing you, I can see you. How many of you found this at least, let's say, 50% exciting? You heard for last 1 hour. Can you raise your hand? So, gained this session to further explore that, read on that, right? Information is available on the internet. Definitely, I can give you some more insights in the guide. Yeah, Sita, so let's take some questions.
Okay, do we have some questions? We can have like 1 or 2 questions quickly. Any questions?